Question 3 from the June 18 higher paper, Unit 2, or question 13 from the intermediate paper. This is a trial and improvement question. We're given this quadratic to have a look at, and we're told a solution lies between 4 and 5. So a couple of things about the best way to approach these. We can't do the usual technique of trying to do the same operation to both sides, so that we're just left with an x. Because we've got this cubed in here and that makes it a bit tricky, and we've got the x as well, so it becomes a bit more awkward. It's not a quadratic, so we don't have an x squared as the highest power, so we can't factorise or use the formula or possibly even complete the square. So what we've got to rely on is some systematic working, and to do that it's a really good idea if we use a little table. We have 3 columns in our table. We have the x value, we have our bit of working out where we work out our values and what we're aiming for, and we just make a little note so the examiner can see what's going on, whether our answer is too high or too low. And then our final step is we must check the midpoint, and I'll show you what I mean as we go through. So let's crack on and do this question, and we'll see how we go. So it says a little reminder, you must show all your working, so it's completely fine to put that in the table. So I like to check that 4 and 5 are at either side of this answer. So these are values of x I'm going to put in, and one should give me an answer that's bigger than 0 and one should give me an answer that is below 0. And I quite like putting them in because it shows I'm using my calculator correctly, I've got everything set up and I know where I'm going. So first of all, if I put 4 in, so 4 cubed minus 7 lots of 4 minus 51, and my calculator tells me it's minus 15. So I'm just going to write that down in my table, because remember your examiner cannot see what you've put into your calculator, so I have that written down. Now I'm aiming for 0, and this gave me minus 15, so this is too low. I then put 5 in just to check, so 5 in there, 5 cubed minus 7 times 5 minus 51 gives me 39, and remember I'm aiming for 0, so this is too high. So then I'm going to go somewhere in the middle, and this is slightly, I think my answer is going to be slightly closer to 4, because minus 15 is slightly closer to 0 than 39, so I'm just going to have a guess, I'm going to go for 4.2. So I'll put 4.2 in, and I get negative 6.312. Again, this is too low. I'm trying to get to 0, but it's getting closer. So then I'm just going to go in 1 decimal place steps. I'm going to go 4.3 next, and getting closer again to 0. That gives me 1.593. It's too low. And when I put 4.4 in, I've jumped to get a positive answer, which is 3.384. So I know this is too high, because remember I'm aiming for 0. So I've done quite a lot of work now. Bit of number crunching, got some answers out, but I haven't quite got the right answer. I've got to find my solution correct to 1 decimal place. So it's got to either be, because these are to 1 decimal place, 4.3 is slightly too low, and 4.4 is slightly too big. And it would be really easy to have a guess and just write down, oh, I think it's going to be 4.3. But the last bit of my kind of thinking or my steps to success, you must check the midpoint. So because you know that this one was too low, this one was too high, your 4.3 and your 4.4 are the useful ones. They are interesting. My answer is going to be one of these. I have to check the midpoint. So the midpoint of 4.3 and 4.4 is 4.35. So I pop that in to the equation, and I write down my answer in my table, but 4.35 gives me 0.863. And then I just have to do a tiny little bit of thinking. This answer is still too high. So 4.35 gives me an answer that is too high, so I choose 4.3, which is below it, and that is my answer to 1 decimal place. It does feel a little bit like sometimes that you could have guessed that this was going to be too high, but don't risk it. There's an extra mark in the mark scheme for you doing an answer to 2 decimal places, and the easiest one to use is always the one smack bang in the middle of your 2 answers. So 4.35 means you can choose whether it's above or below. So 4.3 to 1 decimal place. If we just have a quick look at the graph of this to see what's going on, you're not expected to do this, but this is just so you can see what's going on. Here I've got the graph plotted of x cubed minus 7x minus 53, so it's interesting to see. So I'm just going to play through this, and I'm just going to pop in the values from what we did in our trial improvement. So I popped 4 in, and I got minus 15. When I popped 5 in, I got out the 39, so you can see that I'm trying to get this point where it crosses the axes. So then I went for 4.2, and I'm still getting a negative answer, and I'm going to zoom in a bit so that we can just refine it. So we're trying to find where the red line is crossing the x-axis. So I've tried 4.2, so next I'm just going to be systematic, I'm going to go 4.3, and you can see it's getting smaller and smaller, we're getting closer, but I'm still below. If I go 4.4, you can see we jump above. So then remember what we did next when we got 4.3 and we got 4.4, we tested the midpoint, because we don't definitely know what that red line is doing. So I checked the midpoint, 4.35, and again this one comes out to be positive, just like 4.4. So that 4.35 is too high, so we know we can take 4.3 as our final answer to 1 decimal place. Just a follow-up question then, still a trial and improvement, but with a slightly different setup. So the difference is that this time, instead of being equal to 0, we've got x cubed plus 4x, and this time we've got an equation that's equal to 10. So instead of looking for above and below 0 or trying to get our answer as close to 0 as possible, we're now looking at 10. Again to 1 decimal place, and we're told a solution lies between 1 and 2. So I know I need my table, and I'm going to check 1, and that gives me 5, which is below 10, and then I know that's too low, and then I'm going to check 2. And I pop 2 in and it gives me 16, which is too high. So they're fairly well spaced, so 5 is 5 below 10, and 16 is 6 above 10, so I'm going to smack bang in the middle, I'll go for 1.5. That gives me 9.375, which is still too low. I'm getting closer though, so I'm just going to go 1 decimal point at a time. So now I go to 1.6, or 1/10 I should say, 1/10 at a time. So now I go to 1.6. If I pop that in, I get 10.496. Now this is too high. Okay, so I know my answer straight away without too much working out is somewhere between 1.5 and 1.6. So I have to make a decision, and I have to check my midpoint. So the midpoint I'm going to use is between 1.5 and 1.6. So I'm going to check 1.55. So when I pop that into the equation, I get an answer out of 9.924 with a bit of rounding, and I can see that is still too low. So because that's too low, I know I need to take the answer that is slightly bigger than the 1.55. So I'm going to say that my answer is 1.6 to 1 decimal place. Okay, so again, the same system as before. Table of values. I always check the ones that they've told me to make sure that my understanding of how to put the numbers into this function is okay. And I've narrowed it down to being between 1.5 and 1.6 because 1 is too high and 1 is too low. And then I check my midpoint, so I know that that's 1.55. And when I know that 1.5 is too low, my answer must be bigger than that, so I go to 1.6. Just out of curiosity then, let's have a little look at the graph of what's going on here. So I've got x cubed plus 4x is this red line, red curve, and I want this to be equal to 10. So I want where it crosses this black line of y equals 10. So fine. Click play on that so we can have a little look. And if I plug my numbers in, first of all I'll pop 1 in, and you can see that that's below it, the blue line, below the y equals 10 line. I pop 2 in and you can see it's above it. Then I go to 1.5 and straight away I need to zoom in a bit more, and you can see that 1.5 sits below that point and it's giving me a less than. So let's try 1.6, and it's slightly bigger than the 10. So then I can go to my 1.55, and again you can see that it's below it. And so that value we want where it crosses that black line is somewhere in between 1.55 and 1.6. So 1.6 is my answer to 1 decimal place. I hope that was useful.